Hi kids, we're going to wrap up chapter 5 by taking notes on 5, 6, and 5, 7 together. In these sections, we're going to be proving that we have a certain type of quadrilateral, or trying to figure out, hey, I've got a four-sided figure, what type of quadrilateral is it? So there are certain tests that we can do to determine this. Make sure in your notes that on the left column you're writing any questions or points of confusion so that way when you come back to class the next day you can ask your questions. Okay, so here is the first list of tests. If you can prove that any of these 5 are true using your math or your algebra or a formula, then you've got a certain shape. Okay, so see this square looking shape to the side? That's not a square, it just represents any kind of quadrilateral, a four-sided shape. Look at the first test. If you can show that both pairs of opposite sides are parallel, so those two and those two, and you can do this by finding the slopes of opposite sides would have the same slope. That's one test. Or test 2, if you can show that both pairs of opposite sides are congruent, meaning they have the same distance, there's another test. Or number 3, if you can show that one pair of opposite sides are both parallel and congruent, so they have the same slope and the same length. Or you can show that the diagonals bisect each other, meaning these two halves are congruent and these two halves are congruent. So again, you're looking at length. Or if you could somehow show that both pairs of opposite angles are congruent. So these two are congruent and this pair of opposite angles are congruent. If you can show that any one of these 5 are true, then your quadrilateral, it's a parallelogram. Now, if you want to be more specific and figure out, okay, I know it's a parallelogram, now I want to figure out what kind. Is it a rectangle, a rhombus, a square? We've got other tests for that. But these are the 5 tests to prove that you have a parallelogram, or to see if you have a parallelogram. So here are 3 other tests to determine another type of quadrilateral. Let's say you have a quadrilateral, you have no idea what it is. If you can, 1, show that all 4 angles are right. And we can do this by looking at slopes of consecutive sides. That would mean 2 sides next to each other, like this side and this side. If you can show that their slopes are opposite reciprocals, then that angle where they meet, that's a right angle, and you would have to do that for all 4 corners. So that's one of the tests. Or if you did that parallelogram test, used one of those 5 to show that you have a parallelogram and at least one right angle. So again, you saw that 2 of the consecutive sides had opposite reciprocal slopes, then you have this certain shape. Or number 3, if again you've proven that you have a parallelogram from one of those 5 tests that we've just talked about, and that the diagonals are congruent, then what you've got, then it's a rectangle. And now that you know it's a rectangle, you know that it has some other properties. So here are 3 more tests to prove that we've got another type of quadrilateral, which we'll talk about which one it is in a minute. The first test, if you can show that diagonals are perpendicular bisectors of each other, which means not only do they intersect at right angles, which means the diagonals would have to have opposite reciprocal slopes, but they also cut each other in half. So the halves of each individual diagonal are congruent. If you can show that those distances are congruent, then you have this shape. Or number 2, if you have just proven that you have a parallelogram using one of those 5 tests, and you can show that that you have at least one pair of congruent consecutive sides, so two sides next to each other would have the same length, or number 3, if you have just proven that you have a parallelogram by one of those 5 tests, and either of the diagonal bisects a pair of opposite angles. So like those 2 angles are congruent and these 2 angles are congruent. Then what you've got is, it's a rhombus. To prove that you have this particular shape, you only have to do one test. But in that test, there are 2 tests. So one part of the test, you need to show that this shape is a rectangle by showing that one of those 3 rectangle tests is true. And the other test within this test is that you need to show that you've got a rhombus by showing that one of those 3 rhombus tests is true. If you can prove or show one from each of those, then you have a square. So those are the parallelogram family proving tests. Okay, so to prove that you have this particular shape, you first need to have a trapezoid, which means you need to have one pair of opposite sides that are parallel, meaning they have the same slope. That's the first caveat of all 3 of these tests. Look at 1. So you've got a trapezoid and the non-parallel sides are congruent. So these other 2 sides are congruent, they have the same length. That's one test. Or if you have a trapezoid and either the lower or upper base angles are congruent, so you could do one or the other. You could say these 2 guys are congruent, or these 2 guys are congruent. The last test for this shape, if you've got a trapezoid, then if you can show that the diagonals are congruent, meaning they have the same length, now you want to show that, then your shape, it's an isosceles trapezoid. Yay. All right, we have one more group of tests. All right, last group of tests. If you've got a quadrilateral and you can, number 1, show that you have 2 pairs of congruent consecutive sides. Consecutive means they're next to each other, so these 2 sides are congruent, they have the same length. And these other 2 sides are congruent, they have the same length. There's one test. You have this shape. Or number 2, you can show that one diagonal is the perpendicular bisector of the other. So let's say that first diagonal I drew not only intersects this other diagonal at a right angle, but it bisects it into 2 congruent halves. And if you remember this picture, this is from that little worksheet we did in class where we had the different square looking shapes and we had to name the most general shape it could be. This one was the last one. Then, if you can show that either of these is true, then it's you guessed it, it's a kite. So you're probably wondering, why do we have all these tests? First of all these tests would be great to put on a note card for your test. But second of all, these tests actually help us save a lot of time. If I had a quadrilateral, for example, and I wanted to show that it was a square, if you look at the list of all the properties of a square, there's about 10 or so. If you were to prove that all 10 of those were correct, you'd be working forever. So the cool thing is you just have to prove one of these tests is true, and then you have that shape. So it's kind of like a little shortcut. It's very similar to when we were proving triangles congruent. We know that when we have 2 congruent triangles, we have 6 pairs of congruent corresponding parts. But by using SSS, SAS, ASA, or HL, we only had to prove 2 or 3 things were congruent, not 6. So it's a shortcut, kind of like those were. Let's go ahead and do a couple examples. Okay, for these types of questions, there will basically be 2 types. They'll either say, show that you have this particular shape. In this case, we have a parallelogram. Show that you have a parallelogram. Or it might say, what shape do you have? In that case, you're going to have to run through all the different tests. Go with a hunch first, and that way it'll help you narrow it down a little bit better. But for this example, show that it's a parallelogram, we've got 5 tests to choose from. So you want to choose the test that's going to be easiest for you. If you take a look at the 5 tests that we wrote down previously at the beginning of our notes, the first test, we're going to be looking at slopes. The second test, we're going to be looking at distance. The third test, we're going to be looking at slope and distance. And the fourth test, we're going to be looking at distance. The fifth test, we're going to be looking to see if angles are congruent. That's going to be a little bit harder because we would probably need to come out with like a protractor. There's not really a formula that shows you how big an angle is. So the fifth test is probably not going to be the easiest. So we want to either use test 1, 2, 3, or 4 for parallelogram. Okay, so it's kind of up to you what you want to choose. Me personally, I think slope is pretty easy to find. So I'm thinking of either test 1 or possibly test 3. Test 3 would be to show that you've got one pair of parallel sides and that pair is also congruent. If I look at PQ and SR, I could count the lengths of those, so I could really easily tell if those 2 sides were congruent or not. So I think for me, I might choose either test 1 or 3, but that's just me. So I'm going to choose test 3. For test 3, it says one pair of opposite sides are both parallel and congruent. So these opposite sides I'm going to be looking at are going to be PQ and SR. All right, let's start with the easiest. The easiest would probably be to determine if they are congruent, and I can just count that. So for PQ, I'm going from a -10 x value to a +2. That's going to have a distance of 12. And for SR, I'm going from a -7 x value to a +5 x value, which also gives me a distance of 12. So those 2 are congruent. The second part of the third test is to prove that those 2 sides are parallel. Well, I can also really easily see that they're parallel because they're both horizontal. They both have the same slope of 0. So sometimes there's not a whole lot of work required. However, if I wanted to show that PS and QR were the congruent sides that had the same slope, I would need to get out some formulas. So kind of be smart when you're picking these tests, which ones to use, so that you don't have to do a whole bunch of work. So based off of these 2 things, I know that this is a parallelogram. Let's take a look at another one. So here's our last example. It says, what is the most descriptive, it should say name, for quadrilateral ABCD? So this is an example where we have no idea what kind it is. We're not trying to prove it's a particular given kind that they want. So when you've got coordinates like this, it really helps you if you can actually graph it on graph paper like I've done, because when you do that, you're drawing it to scale, pretty close to scale. And then you can come up with a pretty good hunch. Like, to me, this kind of looks like some sort of rectangle parallelogram thing. I'm not thinking it's a trapezoid or a kite. My hunch is it's some kind of parallelogram. So I'm going to start with one of the parallelogram tests. If it works, then I might try to narrow it down to a particular type of parallelogram. Out of the 5 parallelogram tests, we said the first 4 were probably the easiest to try to prove, and I always like looking at slope. So I'm going to look at I'm going to use test 1 for parallelogram, which says both pairs of opposite sides are parallel. So I need to find the slope of all four sides. You can do this by using rise over run. You can use the slope formula. I think I'm just going to use the slope formula. So first I'm going to find the slope of BC. Let's see where I should do this. Okay. So here, let me do it over here by BC. So the slope of BC, I'm going to subtract my two y's. So 9 minus 1. And then I'm going to subtract my two x's. So 3 minus negative 9. That reduces to 8 over 12, which then reduces to 2/3. So the slope of that segment is 2/3. I'm going to look at its opposite side, which would be AD, and just to see if it's got the same slope. So the slope of AD, I'm going to subtract my y's. So I've got 1 minus negative 7. Subtract my x's on the bottom. So I've got 9 minus negative 3. And then when we simplify that, we get 8 over 12, which simplifies again to 2/3. So I've just shown that I have one pair of parallel sides because they have the same slope. Now I'm going to take a look at the other two sides. Let's take a look at BA first. I'm going to do it right here. The slope of BA, I'm going to look at my y values. 1 minus negative 7. My x values, negative 9 minus negative 3. That equals 8 in the top. Negative 9 minus negative 3 is like negative 9 plus 3, which would be negative 6. And this is going to simplify to negative 4/3. That's the slope of BA. Now I'm going to take a look at the slope of CD, its opposite side. Subtract my y's, 9 minus 1. Subtract my x's, 3 minus 9. That equals 8 over negative 6, which also simplifies to negative 4/3. So since those two sides have the same slope, I know that these two sides are parallel. And since I fulfilled test 1, I know for sure that this shape is a parallelogram. But it says the most descriptive name. Well, I need to see if it could be one of the special types of parallelograms, either a rectangle, rhombus, or square. In order to be a square, it's got to be a rectangle and a rhombus. Let me consider rectangle first, because in rectangle, if I look at those tests, I've got one that says all four angles are right angles. Well, in order for them to be right angles, consecutive sides would need to have opposite reciprocal slopes. So for example, if I take a look at the slope of CD and the slope of AD, this guy and this guy, they are opposites, but they're not reciprocals. So I know right there, I don't have four right angles, so I have disproven that it's not a rectangle, which means it also could not be a square. So let's consider rhombus. Let's take a look at those tests for rhombus. Diagonals are perpendicular bisectors of each other. We can consider that. Parallelogram and a pair of congruent consecutive sides, so we would need to look at the lengths of the sides. Or number 3, parallelogram and either diagonal bisects a pair of opposite angles. I don't know exactly how I would test that with what I've got. I can try to do number 1, which says diagonals are perpendicular bisectors of each other. So I'm going to go ahead and switch my colors. Let's take a look at the diagonals. This is going to get a little messy. Actually, let me pause it and clean up for a sec. Okay, so just to recap, we've proven this is a parallelogram. I'm trying to now prove if it's a rhombus. I'm looking at test 1. Are the diagonals perpendicular bisectors of each other? So I kind of sketched them in. For them to be perpendicular bisectors, they would need to intersect each other at each other's midpoints. So I'm going to first try to find the midpoint of BD. Well, if I look at the x values, if I look at their y values, they have the same y value, B and D. which means that diagonal is completely horizontal. So I can count where the midpoint is. If I look at the x values, it goes from -9 to +9, which means the midpoint is right at 0. Okay, so I need to see, so this point, the midpoint of BD, looks like it's at 0, 1, this point right here. Now, I just sketched this. I don't know if my sketch is right, my other diagonal. If my other diagonal has the same midpoint, then that means they're bisectors of each other, which is great. But then we would need to show that they are perpendicular. I'm pretty sure that the diagonals are going to be bisectors of each other because we have a parallelogram and parallelograms bisect each other. But just to kind of make sure, the midpoint of AC is going to be the average of the x and y values. So x values are going to be 3 plus -3 divided by 2. The y values are 9 plus -7 divided by 2. And when we simplify that, we get a midpoint of 0 divided by 2, which is 0, and 2 divided by 2, which is 1. So yes, they do have the same midpoint of 0, 1. Great. Now I need to show that they're perpendicular to each other, which means their slopes are going to be opposite reciprocals. I can already see that they're not. That's the cool thing about doing stuff in a coordinate grid. If I know that this first diagonal is horizontal, if the other diagonal was to be perpendicular to it, it would need to be vertical, and there's no way it can be vertical because I can see clearly that it has to cross the y-axis somewhere. So right there, I know that they do not make a right angle, therefore it's not a rhombus. I already know it can't be a rectangle or a square. That means it's just a plain-o parallelogram. Okay, so that's it for the set of notes. I know it's kind of long, but set aside any questions you've got, and we'll go over them in class. Have a good evening.